So hello everybody, thank you all for coming. I kind of volunteer with CCF for various things, but you'll be delighted to hear that I am not your main speaker today. We have a far more expert person, but I will get started. I will share my screen with the presentation. No, not that one. Microsoft PowerPoint, and then
right, that looks good.
No, I want to go into this, sorry, slideshow. Here we are. So you should be able to see. Can you see my screen now?
Good. Yeah.
Okay. Yes. So just to make sure that you have come to the right event, we are going to be talking about heat pumps today. And it's going to be about an hour and a half, and our main speaker is Andy, and Tom's going to talk a bit about his heat pump as well, and I'm just going to disappear after the first few slides and monitor the chat. Actually, I can't monitor the chat, Nicole, because I'm doing the presentation. We'll see what happens. Right. So, rules for the day. I'm sure you've had this sort of thing before. As there are rather a lot of us, please keep your microphone off unless asked to contribute. Otherwise, we get far too much background noise. If you want to ask questions, please do use the chat. Nicole is going to monitor the chat all the time. And yes, hello, Nicole. Thank you. And we will interrupt Andy if needed, if it's a clarification question. So if it's something you don't understand, or, you know, what's that on the graph or something, then that's great. But if it's some more general questions, we're going to have two question and answer periods, one sort of in the middle and one sort of at the end. Well, it will be at the end. We are recording. If you don't want to be on the recording, please could you put your make this known in the chat. So, and then when Tom edits, he will make sure you're not in it. And we will make available the slides, so you don't need to take copious notes on what the slides are doing. We will make the slides available very soon after the event. In fact, we've already got it ready on a PDF for you. So I just thought I've got one meaty slide here. Why do we want a heat pump for our home? The reason we want a heat pump for our home is because it's the best option for decarbonising heat, pretty much, especially at the moment. A heat pump gives us electrical heat, which is extremely efficient compared to everything else, and has the potential to be completely zero carbon, because electricity can be zero carbon. You may have heard in the news discussions about other options like using hydrogen for heating, which is theoretically possible, but is likely to be expensive, and it requires a huge amount of infrastructure to be built. It's going to take ages to get that going. And anyway, it's much less efficient, because with a heat pump, you can have 1 unit of electricity supplying 2 or 3 or maybe even 4 units of heat. Whereas with hydrogen, if you're starting from electricity, you convert it to hydrogen, so that's about 80%. And then you've got to transfer it around, and then you've got your boiler, and it all goes down to about 50%. So why would you have a 50% efficient system when you can have a 200 or 300% efficient system? You know, fairly obvious. Well, it's not quite as simple as that. And there are also possibilities of having a hybrid system, which would be like a heat pump with a gas for backup. But at the moment, your heat pump is your best option that you can put in now. So it's definitely a possibility. And is it affordable? Electricity is expensive, but with this extra efficiency and with flexible tariffs for electricity, if you have a smart meter and you can go onto a time of use tariff like Octopus Agile, you can get electricity at about 9p, of the order of 9p a kilowatt hour, which is less than twice what you're probably paying for your gas. And you should be getting more efficiency. So actually, in terms of the energy cost, it should be about the same. Swings and roundabouts, not exactly the same, obviously, but in that sort of ballpark at least. And there is a renewable heat incentive that's been going for quite a while. So if you get a heat pump installed, you can get a subsidy for actually installing it. And at the moment, you can get more of a subsidy as well from the Green Homes Grant, but you have to be quick off the mark for that one. It isn't a totally trivial exercise, otherwise we wouldn't be here discussing it with you. There are quite a lot of changes that you need to do, And that is why we have Andy to tell us all about it. Andy, I ran into him virtually because he gave one of the talks in the Carbon Co-op heat pump seminar series earlier a few months ago, which was absolutely great. And he's a very good speaker. He's not a local man. He lives in the Peak District, but with Zoom, that does not matter. Thank you, Andy. We don't have to have a local person anymore. We can have someone who really knows. He's got a heat pump at home. He's had things for several decades. There have been upgrades. You know, he's not all, he knows the up-to-date stuff as well. And the main thing is he really knows how they work and how to get the best out of them. His expertise is in urban sustainability in general. You know, this is absolutely in his area, but it's also personal as well, which I think is a great combination. So, Andy, over to you.
Okay. Yeah, this is actually it's a bit of a concentration, this presentation, of several presentations I've done for the Manchester Carbon Co-op. So I hope it doesn't seem too much of a blur. Right, next slide. Okay, the dedication of this presentation is to shelter, because I know we're all talking about the future of homes, but if we look at what's happening currently, there are people in real problems because of the COVID eviction moratorium ended on the 1st of October. So people are now facing eviction because, and it may be because they lost their job in, you know, some of the COVID stuff. Incidentally, in the States, the moratorium they have there on evictions is carrying on. It's not stopping like it is in the UK. So please help Shelter to address this issue. I'm not charging a fee for this talk, and I think you're getting it for free. So give what you think is appropriate to Shelter or to Cambridge footprint, carbon footprint. Okay, next slide.
Sorry. Where is it? Ah.
Oh yeah, right, content, right. Okay, I'm going to talk about some of the technical aspects, but I'm going to concentrate particularly on performance, how you get the heat pump to perform, how you avoid some of the problems such as cycling, and one of the flow temperature is a key thing. I'll explain these issues. And what we're about is effective systems and how to get an effective system installed. Okay, next slide. Right, and I've divided the talk into 3 topics: the heat pump challenge, heat pumps, are they a retrofit solution, and the procurement process, i.e. how you get your heat pump. And in fact, most of the presentation is going to be on this procurement process. But let's start off by looking at the heat pump challenge. First thing is, can you apply the technology? You need to have some knowledge of heat pumps to be able to, before you actually go and, if you like, get an installer. Then the thing is, will your installer be able to install an effective system? Unfortunately, some installers have just jumped into this because they think, oh, it's a big expanding market, we'll go in and make a killing, as it were. Although there are some who are trying to do the job well, and actually, you know, they're missing some of the important rules in terms of heat pumps. And then, of course, there are the installer who are not really motivated. They're much more into it because it's the money's there, as it were. So anyway, let's now have a look and see how we go ahead. Is it a retrofit solution? Well, some of the early reports are a little bit discouraging. The first report in 2008 of the Energy Saving Trust gave heat pumps with an average COP, that's coefficient of performance, over the year of 1.8, i.e. you put 1 kilowatt of heat in and you got 1.8 kilowatts out over the year on average. with a bit of massaging of the figures, they managed to knock this up to 2.82 by just only looking at Mitsubishi, Daikin and Grundfos systems and improving the systems, right? I think it's very interesting that Mitsubishi and Daikin are there. To my knowledge, they are the good guys in this, you know, in terms of manufacturing of heat pumps. And it's no surprise that they're both Japanese. I'll come into that later. Right, so then, is it a retrofit solution? Well, not all by itself. You've got to get the basics of retrofit done. You've got to do the insulation, look at solar gain, and I'll mention that again, air movements, thermal stores. Thermal stores particularly useful if you've got a heat pump, and I'll go into that later. And there is a need to reduce the heat loss generally to the output of the heat pump at the time of installation or later. So what I mean by this is think ahead. If you're going to do a big retrofit but you want to put the heat pump in first for whatever reason, size your heat pump according to your planned heat loss. Now, here's the thing that some people will think is a bit odd. I'm saying if you calculate the heat loss and that's when it's to keep the heat, when it's 20 degrees inside, the heat that's going out of the house when it's 0 degrees outside. I'm saying if it's 6 kilowatt, only put in a 5 kilowatt output heat pump, okay? And you might think that's a bit odd, but the big thing with heat pumps is that if you oversize them, you're causing a huge increase in cost. It can double the cost of running them, okay? And the nice thing about a 5 kilowatt heat pump is generally when it's running, the input of electricity is only 1 kilowatt. And there is an issue people are saying about where are we going to get all this electricity from? Is it going to overload our current cables and so on? Well, it won't if we can put in heat pumps which only have a 1 kilowatt input. Okay, next slide. Right, so we're into the procurement process. You've got to decide on the heat pump to be installed. And you should be very involved in this. Don't leave it to the installer. It should be the type of heat pump, make and model, and the output size. And again, yeah, that's an important thing to get the output size right. Then when you've got a fair feeling for that, and only then, choose an installer. With the installer, design the system. Then after that, you've got the installation process where it actually gets put in. And then finally, and very important though, is the daily operation of your heat pump. You can really improve the efficiency of the heat pump by operating it correctly. And lastly, you need to get all 5 of these right. It is important to with a heat pump, if you fall down on any of these, you will have you'll have efficiency problems. You could have efficiency problems. Some are rectifiable, some are very difficult to rectify. Right, next slide. First thing is decide on the heat pump to be installed. Okay, so the next slide, we'll see the different types. There's the ground source heat pump, suitable for new buildings. Water source, you've got to have a suitable water source. River Thames. There's a lovely Swedish airport where the whole airport is heated by heat pumps and the heat is taken out of the sea. And then there's air source heat pumps. Air source heat pumps, very easy. We've got air all around us and we just pull it out. Some people think of ground source heat pumps as being the best, and in fact you get a higher grant for them. But there are reasons why ground source heat pumps are not suitable for retrofit. Next slide. Some people think I'm prejudiced against ground source heat pumps. I'm not actually. It's just that they're good in certain areas. They need extensive excavation or boreholes to collect the ground heat. And they do quite often suffer from airlocks and whatever in the heat collection system. And they're expensive. £10,000 plus. It can be £5,000 just for the borehole. Right. They are an option for new build domestic or larger buildings. Because if it's new build, you've got the excavator on site, you can plan it all beforehand and get it all sorted. There is a company, Rendesco, that have a system for putting in ground source heat pumps in new build care homes. And incidentally, just to show I'm not prejudiced against ground source heat pumps, I've invested a fair chunk of money into Rendesco, and it pays me 7% per year interest, which is just an illustration that green investments can be very good for the planet and good for the pocket. Right, okay, next slide. Can you go back one?
Sorry.
Right, okay. Air source heat pumps. High reliability potential as factory built. So if the factory is a good factory, great, you've got a good heat pump. Unfortunately, there are still a lot of heat pumps that are not all that brilliant. So your first major decision is what heat pump manufacturer to go for. The main unit is external, which is good. It doesn't take up too much space inside. Depending on the type of heat pump, some are split and have some bits inside and half of it outside. There's a potential to perform well in a mild climate. A few days in the year below 3 degrees is very good for a heat pump. Its performance is to do with the temperature difference between outside temperature and inside temperature. And 3 degrees is a critical temperature, because below that temperature you can get icing in the heat pump, and then the heat pump has to do a reverse cycle to get rid of the ice. If you've got a warm air source, brilliant. So try and position your heat pump in a sun trap or where it gets the sun, or extract heat from the London Underground, which has a lot of warm air. And as I think I said before, this system they've got where well, many properties and so on are heated by a London Underground air source heat pump, and they're putting more in all around the underground. So, you know, there's some clever solutions that we can use with heat pump technology. These can be a replacement for a gas boiler, and they run at but they run at lower temperatures, so that's an issue that you have to deal with. And the cost is $2,500. That gets you the basic unit. If you've got all the other plumbing there, you can just put the basic unit in. Generally, though, you're going to have to spend a bit of money on your radiators and whatever. My original system for my air source heat pump was £6,000. Incidentally, it wasn't the first heat pump I had. I had a water source heat pump that was built for me by John Cantor. Right, I think we might have missed that slide somewhere, but somewhere you should get information about John Cantor, his book and his website. I was very fortunate to help him build my water source heat pump in 1993. 94, I think we built it. And that was great. It ran at efficiency of 4:1. But of course, I had the water supply. Unfortunately, the water supply has dwindled, and I had to abandon the water source heat pump around 2009. Okay, next slide.
Sorry, hang on. Ah,
Right, this is my house. Notice the south-facing conservatory, which is all part of my retrofit plan. That adds quite a lot of heat to the building, particularly useful in the spring. Actually, that's where you get the best benefit from it. Right, next slide. And here's the heat pump. That little system, well, the beige system there. Incidentally, if you've got a small heat pump, the dimensions are about 1 meter by 1 meter and about 500 millimeters, half a meter, projecting from the wall. Notice on the left-hand side of that slide is an extension which was built to pretty much to passive house conditions, requirements. And not only has that stopped the heat going out of the north wall, it's also converted the north wall into a 28-ton storage heater, which means I can be very flexible about the way I use my heat pump, because I'm not, I don't have to have a continuous amount of heat going into the house. I can run it for 2 or 3 hours and then leave it for 6 or 7 hours or whatever. Right, next slide. Right, heat pumps, air to air. The air to air heat pumps are a fairly new innovation in the UK. And effectively, the heat pump feeds a fan heater, right? And it's great if you say, like, you've got an open plan living space. Some people knock through the downstairs rooms to make it open plan, and an air-to-air heat pump is really good in that condition. They cost from 500 quid, but you won't get much for that. You're better off getting one, paying 1,000 quid or more. And they can be mobile or fixed to an external wall, normally fixed to an external wall. For some reason, this is an old slide, because rather than having the idea of them showing promise, I do know, and Tom will tell you about installations where they're good. Incidentally, they've been around for quite a while in Canada and Australia, and only recently come into the UK. So it's not as though they're unproven. And I think the next slide is Tom's, is that right? Oh, no, it's not, sorry. Okay, right. So, yeah, supplementary heating. The BRE research shows that an air source heat pump with output less than the heat loss at 0 degrees, supplemented by direct electric, can be more efficient than an air source heat pump matching heat loss. What I mean by this is that people think, well, if in the middle of winter you've got to put a fan heater on because your heat pump isn't giving out enough heat, well, then the heat pump over the year will be inefficient. But it won't, because matching closely to the it won't, because when you add in the heat you've used with the fan heater and electricity used in the fan heater and the electricity input to the heat pump, because the heat pump is working more efficiently, the total amount of electricity used will be less. Okay, now that's BRE. It's on their website. You can have a look and see what they say about it. Supplementary heating, of course, can be a wood stove, and it could even be a gas fire. Some people have hybrid systems where you have gas fire and say an air-to-air heat pump, so that, for instance, you're cutting your gas consumption by 50% or more because a lot of the heat is coming from the air-to-air heat pump as a cheap retrofit intervention. Right, I think it's now that I hand over to Tom.
Tom?
Oh, Tom, you're muted at the moment. You'd have to unmute yourself. So, what
I'm
we've got
here.
here, that's it.
Okay, shall
Right.
I do it? Sorry about that. So yes, this air-to-air heat pump that we had installed in February by Anglian Energy Solutions. So it's a Hitachi 3.2 kilowatt unit. And so it is really like an air conditioning unit. And this is the inside unit mounted high on the wall. And this blows warm air down onto us. And so far we found it really effective. And because it's heating air to maybe 25 or 30 degrees, a lower output temperature than a lot of wet systems, it should have a better COP, although it's hard for us to measure that. And so this is relatively easy to install. And this unit's, the full installation was 2,250, including that. And so it is an air conditioning unit. It could be used for cooling in the summer, which we definitely don't intend to, because we've got very nice shading and other arrangements working out for being cool during a heat wave. And can you press it again, Nicola? I think it'll bring up the but section. But these air-to-air heat pumps only normally heat one room. So in our case, it's heating a fairly open plan downstairs room at the back of our house, where we're also having solid wall insulation done. And then in the evening, we tend to go to a sitting room at the front, where we have a wood stove. And so with using these two, our reasoning was, if we use these two, then most of the winter, unless it gets really freezing, we won't use our gas central heating. We have that as a backup, and we probably will have to use it when it's really cold. But this is our low carbon solution for the moment. And the other disadvantage of air-to-air units is they're not eligible for the renewable heat incentive, because you might be installing it just in order to have air conditioning in the summer, which they don't want to subsidize.
Sorry.
Okay, Tom, before you go, can you
Sure.
give us a rough idea of how often you would use the gas central heating in the winter?
So we don't really have, we haven't had a full winter with this heat pump installed yet. We only hit in February. But in general, we tend to use the gas central heating in short bursts and when it's pretty cold. And then, you know, when we kind of retire and slow down in the evening to read or telly, then we're in a heated room, but generally a room that's not heated by gas.
You got a question, which is, what kind of house do you live in? It's terrace, isn't it?
Yeah, so this is a turn of the century terraced house, Edwardian terrace, and we're most of the way through, or part of the way through, retrofitting it, but now with imminently we will have doors and windows at the back, and improved ones, and solid wall insulation. We haven't done the front yet.
And can I take from what you're saying that you probably have got a 50% or more reduction in gas?
Oh yes, dramatic reduction in
Right.
our gas consumption. Yes, more than 50 since we since before we had the wood stove and before we have installed
Right.
this, dramatically cut our gas consumption.
Of course, the gas provides the hot water, doesn't it, Tom?
It does, yes. So yes, that's another thing I should have said. Air to air does not give you hot water or warm water, maybe as normal air source heat pumps could do.
Right, thanks for that. I think this is a very interesting development, you know, that I can see air to air coming in a lot. A bit unfortunate the government doesn't want to recognise it, but there you go. I mean, we live with the government we have, you know. Right, thanks for that, Tom. Can we move on? Somebody's talking about air-to-air combined with MVHR. That's a specialist system which actually can work very well. Again, that's a development. And if you have a very good MVHR, which I'm not going to go into, it's mechanical ventilation and heating system. Yeah, you can get benefits from that. Right, so can we move on then to which type of air source heat pump? Well, they come in a much wider range of performance and reliability than cars, right? I mean, there's a variation in the reliability of gas boilers, but actually, you know, the ones that are most sold, the Worcester Bosch, the Weissman, whatever, they're pretty much in a similar range of reliability. Not so with heat pumps. Heat pumps, some of them are just poorly designed. You know, I remember, you know, talking to John Cantor, and he said, well, he knows of some where they just have a really poor heat transfer from one side of the heat pump to the other. And, you know, it's just a bad design. Hopefully they're getting better over the years. But as I point out here, the Japanese have invested £1 billion in heat pump research, and they've given it to their manufacturers. So it's not surprising that a lot of the manufacturers, Japanese manufacturers, know what they're doing. And I was interested to notice that Tom's heat pump is a Hitachi, another Japanese manufacturer. Okay, air source heat pumps can be noisy, but there again, if you get the right one, it's very quiet. I'm very happy with mine. I can stand right next to it, and yes, it makes a noise, but I've heard some computers that are noisier, so it's not bad. 10 years without maintenance is possible. I've had my heat pump now for 10 years and it's never had the cover off it to get inside the working parts. Yes, I'm doing all sorts of stuff with the controls and things, and I've put extra circuits on it and whatever. But that main working unit is just as it was factory sealed, which is quite something, you know. However, if you get the wrong sort of heat pump, you can have all sorts of maintenance problems. And I'll just say again, small is beautiful. Right, let's move on. Okay, expected air source heat pump performance. Well, I first year I ran mine, I got a coefficient of performance of 2.7, which isn't bad. And I think the reason I got that is because it was sized pretty well. When I was talking to the installer, he said, oh yes, you need an 11 kilowatt heat pump. I said, no way, you know. And he said, well, okay, all right, possibly an 8 kilowatt. And he begged me not to put in a 5 kilowatt. But I said, look, I'm having a 5 kilowatt, that's it. And I put it in. In actual fact, it's slightly larger than would be optimal for my particular use, but it works pretty well. I improved it to a coefficient of performance of 3.6. Luckily, I had all sorts of information coming in because I was on the Mitsubishi field trial. And from that, I was able to see how to make the thing work efficiently. And then in 2015, I got really geeky and did all sorts of radiator calculations and so on, because the radiators from the old heat pump were 20 years old by then, over 20 years old. So I upgraded to better radiators. When I say better, more heat emission from the radiators, which meant the heat pump only very slowly built up its temperature and was hanging around in the 30s, the low 30s for quite a while, which made it efficient. Right, Mitsubishi field trial, 60 air source heat pumps, and the coefficient of proficiency is 1.5 to 3.6. Luckily, I was able to get all that data and analyze it over a number of years, and that actually told me a lot about how heat pumps work in the UK. And anyway, the target really, if you've got 2.5, that's okay. If you've got 3 or better, that's good. So when you're thinking about heat pump, don't expect to get more than 3. If you do, it's a bonus. Next slide, yeah. Right, these are the slides. This is the stuff I was getting from Mitsubishi, right? This shows that between 2013 and 2014, I had a COP of 3.6, just over. If you see that green line, which starts off at the top on this graph and then goes down and then comes back again, the COP is the second scale in that goes up to 4. And you can see that for a lot of the time, my heat pump is, 3.5, 3.6, 3.7, whatever. And notice also, though, that the red bars are the heat output in kilowatts, and the blue bars are the heat input in kilowatt. So you can see actually, I'm getting over the winter a big output, and the blue bars are, a fraction, the electricity input of that heat output, and that's obviously what you want. Okay, let's move on. Next slide. Sizing your heat pump, very important. Energy survey needed, because that will help you plan your improvements. I put in my heat pump, particularly the first one actually was just a 3 kilowatt heat pump. I just knew that it was going to be efficient, so I put it in. At the time, I'd done a few improvements on the house, but this was 1993, and since then I've done a lot more insulation improvements and so on. So I thought, well, I'm not having more than 5 kilowatt, even though at the time in 2010 there was more insulation planned. And so the idea is match the output of the heat pump to the heat loss after improvements, right? And a low heat pump output is okay, as heat loss is generally lower than calculated. People who do these calculations quite often say, oh, well, err on the side of caution, let's say it's a bit more than I've actually estimated. And that actually, in terms of for gas central heating, yes, fine, you put in your gas boiler and it doesn't make much difference if it's much, you know, if it's oversized, as it were. It's about 10% difference on a gas central heating system. Whereas for a heat pump, it can be 50%. It can double the amount of electricity you use on it. And another thing you should take into account, I haven't put this into the slide, but it is an important issue, is there's a slight difference between the heat loss, i.e. the amount of heat going out of the house, and the heat requirement from the heat pump. Because the other thing that's happening in your house is that there are people there. Each person gives out about 75 watts. And then there's heating appliances when you're cooking, there's fridge, freezer, television, they're all contributing heat. And it's somewhere between about half a kilowatt to a kilowatt, right? So that isn't part of the heat requirement. That is heat that's generated apart from the heat pump. So that actually, with heat pumps, it is sort of significant. And that's part of the reason I repeat again, 5 kilowatt output if it's a 6 kilowatt heat loss. And the final thing I put in this slide is about a matched pair. As I said, you can have big problems if you put in, say, an 8 kilowatt heat pump, and particularly an 11 kilowatt heat pump when you only need a small amount of heat. Well, when you only want to have a 5 kilowatt heat loss or 6 or 7 kilowatt. What is a solution, though, if you're worried that whether one 5 kilowatt heat pump is sufficient, is a matched pair. You can get a matched pair of heat pumps, so they're integrated, and most of the time only one of the heat pumps will be working. If you've got a large house, big family, 5 bedrooms or whatever, then a matched pair can be a very good system, because you'll find that for 10 months of the year you'll only use one of the heat pumps, but during the middle of winter the second one can kick in. Next slide.
This is where we were going to break for questions, isn't it?
Oh yeah, good point. Yeah. Right,
So
around the questions.
we've had a few. Some of them we've answered as we go along. Nicole,
Right.
You've been keeping track of this. Have you got suggestions to answer now?
Well, maybe we could start with a few shorter questions. So,
Right.
Sarah Wilkinson, if you want to unmute yourself and ask about the design of the roof.
Design of the roof, was that?
Yeah, sorry. So Sarah has asked, she noticed the little roof over the heat pump. Is that always necessary or recommended?
Yes, that's interesting. For most people, it's neither necessary or recommended, but I don't know if we can see that slide again, but I haven't got a gutter on that roof, because that's right. Yeah, there you see, that's how it was built. 1750 house. It was built without a gutter. The water just flows off the roof. However, in a cold winter, I've had icicles up to 1 meter long coming off that roof. And the idea behind that little roof I've put over the heat pump is that if one of those icicles fell off, it could work up a fair velocity and puncture my heat pump. So the heat pump has a little roof on it. It's really a sort of, well, I just thought about it and thought, well, it's a precaution. But no, you don't need them for a heat pump. Most people live in more normal houses. Right.
There's also a broader question from P. Gregory. So I don't know if, would you like to unmute yourself and ask Andy directly?
Hi, Andy. I was just wondering, how are we going to get more uptake of heat pumps if the people who live in the houses and want them installed need to be so knowledgeable in the first place? I mean, I'm guessing 95% of people who need a new boiler ring a plumber or a heating engineer and say, can you install me a new boiler, and rely on them to recommend. So I'm wondering how do we get out of this spiral of needing to
it's a
rely on
very good,
ourselves?
it's an excellent question, that. I know there are heat pump installers getting together to try and form a sort of band of certified heat pump installers, and I really, welcome that. And actually, knowing one of the people involved, I think, that particular group are decent people. I also know that the Federation of Master Builders isn't any organization I would recommend to people. So it is difficult. One of the problems we have, in a way, it's a culture. We have a culture now where we understand gas boilers. And so, you're reasonable about a confidence in getting a decent gas boilers. In the UK, we're a long way behind in terms of heat pumps. If you go, funnily enough, Sweden, which hasn't really got the climate that lends itself to air source heat pumps, they are more knowledgeable there than we are here. And the Germans are quite sophisticated in this area. So yeah, there is a learning process, and unfortunately, it's a learning process for the people who are buying them, as well as a learning process for people installing them. And the real problem you have too is that some people who install just do not understand some of the issues. I mean, I had one guy who told me that it was best practice to put in 15mm piping for underfloor heating. And I told him, well, actually, I don't agree with you, because I know that 25mm is better, and that's what I want. So I told him this, and he turned up and he said, and he had 15mm piping. And I said, well, look, I told you I wanted 25mm. Ah, he said, but you don't understand. 15mm is the right size. So I sacked him on the spot. But the issue is, actually, why it's an issue is that for underfloor heating, if you put glycol in it, radiate, like the fluid to stop it freezing up and whatever, and that can sludge up after a few years. And if you've got a 15mm pipe, you're not going to be able to clear it with whatever pressure you put in. Whereas if it's 25mm, you've got a decent chance of clearing it. And in actual fact, I did have this problem when I had a circuit that had been in there for over 20 years from my old heat pump. And that did take a fair bit of pressure to shift it. Luckily it did. That actually was 20mm piping, but it did shift. And since then, all the other piping's been 25mm. So yes, good question. Hope we can solve it through organisations like this.
Do we have time just for one more? There's been an interesting question about how do you get a survey done?
Right, that's fairly standard. There are people, I don't know, is there anybody in Cambridge Carbon Footprint who does those surveys?
No.
Right.
But I mean, is it like getting an EPC certificate? You go to
well, EPC certificate is a start, right? But you really, it is better to get a proper survey, and an EPC tells you what ballpark you're in. Proper survey should be able to recommend things like, you can, if you put triple glazing in, it will save you so much in terms of heat loss, and then recommend different types of insulation. The name I would put out is Nick Parsons, right? He is based in Sheffield. Unfortunately, I don't think he'd go as far as Cambridge, but you could start off talking to him and see whether he could recommend somebody. And the Manchester Carbon Co-op, who I've worked with a lot, they have their own people who will do a survey. But yeah, no, it's a good point. You should, with a bit of looking around, be able to find somebody who does these surveys. The other organisation is the Association of Environmentally Conscious Builders, and there'll be a lot of people in the AECB who do these type of surveys. And they're a good
When I was looking at
organisation.
getting a heat pump before, the installer came and did a survey for me, but I'm pretty certain that they overestimated my heating demand.
Oh,
So,
this is it. They
yeah.
always do, and sometimes they're a bit sloppy, you know. I mean, if a decent I have, you know, my survey was 14 pages and it covered a lot of detail. When I mentioned that to somebody mentioned car, people say, oh, well, ours are usually a lot longer than that. So,
Okay. There are more questions, but I think it's better if we save them towards the end.
yeah, right. Okay.
Because we could talk for a long time. So
Yeah.
Tell me when to stop, because I'm probably going to go past where we were.
Just back one.
Right.
It was 2, wasn't it? Back to the last. That's it. Okay. Sorry, you were on the right slide. Next slide. Yeah. Okay. Right. Choose an installer. And so, first of all, select a specialist in the make of air source heat pump you've chosen. So I chose a Mitsubishi and I went to look for a Mitsubishi installer. But an approved installer may not be good. Okay. I thought I knew all about heat pumps. Yeah, I'll get this installer in and fine, you know. But unfortunately, a lot of improved installers, all it means is somebody's been on a course at some time in Mitsubishi, and they might have even left the company, and the company still says they're an improved Mitsubishi installer. A good way, because this is what I did, was I went to Mitsubishi and said, who are the people you use to remedy problem installations, right? And they had, I think they had 2 people on their list in the Northwest that they used, right? And I used a company called Dalium, who were brilliant. Very difficult to get hold of now, though, because everybody knows they're brilliant. But do that. Decide on what heat pump you're going to buy, what manufacturer. Go and talk to your local area sort of distributor, whatever, of these, and see who they use for the troubleshooting. The other way is if you know well an installation and it's somebody you can trust, then okay, go with that. You know, if you know that installer's good because you have you can talk firsthand to the guy, to the people who had the installation put in. Well, that's not bad, but don't just be shown. Some installers will show you, oh, look, here we are, come and see this system. And it might be somebody who's sort of reasonably friendly with the installer for whatever reason. So that's not good in itself. It needs to be somebody who you can vouch for. Okay, next on to design. And right, first thing I would say is avoid complexity. Heat pumps can be very complex, and the complex systems quite often don't work. You want something that is less complexity means more reliability, more efficiency. And for instance, if somebody comes in and says, "Oh, I can put you in a high temperature heat pump," and it's got these 2 systems, a split system which takes it from one temperature to here, and then the next one goes up. Avoid it like the plague. There is, by the laws of physics, tell you what efficiency you can get out of a heat pump, and it's directly related to the difference in outside air and the flow temperature through the radiators or through the underfloor heating. And say if you have your heat pump flow temperature of 35 degrees and the outside air is 5 degrees, that's a 30-degree temperature difference. And the physics tells you that the most efficient heat pump you can have will have an efficiency of 9:1. But you can't get 9:1 because, as in most engines, you can only get, I think a steam engine has about 10% efficiency. Car engines are about 30%. With a heat pump, you can get up to 50% efficiency, but you won't get more than 50%. So if you've got a system which runs at 60 or 65 degrees, you're going to get half the efficiency that you would do on one that's working at 30 degrees to 35 degrees. Okay, so monitoring the system is essential for tuning the system to achieve a high COP. And that's really important. The monitoring systems cost several £100, but if you think you're saving £100 a year on the electricity bill, they're worth it. They pay for themselves pretty quickly. And then, yeah, you want low flow temperatures in the radiators, 35 to 40 degrees. I've got a combination of underfloor heating and radiators. And so that works quite well. That I've got, you know, plenty of heat emitters, as it were. So the key to an efficient system is a low output heat pump with appropriate heat emitters, radiators and underfloor heating. Next slide. Design of the heat emitters, right. Sufficient radiators and or underfloor heating. And for underfloor heating, 25mm or larger pipes. I noticed a Grand Designs installation by somebody who was a specialist in underfloor heating. And I think he had, was it 30mm or 40mm pipes? I know he had very big pipes. So I thought, well, he knows what he's doing. Right, high output radiators. You can get single panel radiators and you've got double radiators or triple radiators, and then even fan assisted. When I uprated my radiators, I changed all the single ones for double, and you can get double with what they call them, corrugations inside them, which give off even more heat. So that's worth looking at, planning the radiators well, so that if you don't want huge radiators all over the place, you can replace your gas system radiators with the same size of radiator, which will give out the same heat at a lot lower temperature. So that's something worth looking. And you need the tables for that. There are tables you can get for that type of thing. So you can do that, say, like in cooperation with the installer. I was particularly geeky and worked it all out for myself, but that was just after I'd retired, so it did help. I had the time for it. Right, so check radiator output colks for each room. That's important, that you want to match up the rooms to the radiators. And I think it's probably more important for a heat pump than with a boiler. And I've installed small radiators in buffer zones. My house has buffer zones in that I try and have areas between the living spaces and the outside doors, which are at a slightly lower temperature, whether it's a sort of where the washing machine is, or whether it's going into the conservatory. And so heating in those areas, I don't have any heating in the conservatory, you can economize on. Right, next slide.
It is 1:30, Andy, so we haven't got much to go, have we?
No, we haven't. I'll speed up a little bit.
Okay.
Okay, so this shows a real issue with sizing, that if you have an oversized heat pump, it can be pretty disastrous. And so we've got two slides coming up, one with a poorly set up heat pump and one with a better one. Right, next slide. This thing here, what's happening is that the heat pump is turning off and on every 10 minutes. And if a heat pump turns off and on, it works really inefficiently. And in fact, the little table here tells you the average heat pump, the average COP is 1.13. Okay, so hardly any efficiency at all. So this is what you get if you have a vastly oversized heat pump. It says it's a 2-bedroom flat, and I should imagine it's probably got an 8 kilowatt or 11 kilowatt heat pump in it. Right, next slide. This particular heat pump performs okay when it's cold in the winter, right? Because it's so oversized that it's only starting to get efficient in the coldest winter weather. Right, next slide. Right, this is from my heat pump, which shows it working. You know, no cutting out at all. It's just on for the whole 2-hour block. But what's interesting about this is it's working really efficiency with a COP of more than 5 in the first 40 minutes or so, and then the efficiency goes down slightly. As you can see, towards the last 20 minutes or so, it's still efficient. The COP is still more than 4, but it's starting to work less efficiently because the heat pump is throttling back, right? Modern heat pumps are able to give out a smaller amount of heat rather than turning off completely. But they're less efficient when they do that. Okay, next slide. Installation, right? Okay, check the quality of the work of and that the integrity of the installation is maintained. Take photos candidly, i.e. when the installer's not there in the evening and so on. You don't want to upset the installer. Discuss issues, give them a cup of tea, and it's a good idea to maintain a written communication record. Keep the emails and stuff. There can be the chance that you'll have to change, you know, if your installer's not doing it properly, that you need to get rid of that installer, and you need those written records to show, you know, that he's not done as you've said or whatever. Good luck if that happens. But I had a complete written record when I had to do this with my first, the first installer I got. I did happen to know the law a bit, so I managed to get a shot of him without, in fact, he thought I owed him money, but I said, right, we'll take it to law, and he cleared off. Right, next slide. Operation. Right, operating is important. The monitor tells you the story, and it's worth the cost. And then one of the problems can be the thermostat. If the thermostat is causing the heat pump to cut out, well, then that's a problem. I don't run my heat pump on a thermostat. I run it on the timer. For instance, at the moment, I run it for 2 3-hour periods during the day, a few hours apart. And that's part of the reason I know that, you know, with the average temperature at less than 10, if I was running it at 12 hours a day, which I do in the winter, it would still be efficient. So that it, as a 5 kilowatt heat pump would be, you know, is amply efficient here, amply sufficient for me, right? So then use your monitor to find out whether 2, 3 or 4 hour sessions are good. Cold day performance. This is, some people think that heat pumps can't perform well on a cold day. The next slide shows that they do okay, right? This shows a day when 24 hours, when the temperature is between minus 0.5 and minus 2, coefficient of performance is 2.74. So it's not bad. So don't be put off by people who say that, you know, they don't perform well in cold weather. They perform less well, but it's still okay. And how many days do you get when it's less than 0 all day? Next slide. Yeah, this was the, unfortunately, Mitsubishi switched off their field trial. This is the last month I had out of the Mitsubishi field trial, when I'd been geeky and changed all the radiators and everything. And this shows that you can get good performance even in December. Coefficient of performance there, 4.3. I don't know what the coefficient of performance for the whole year for that, for my current system is. I've only got those few months until they switched it off at the end of 2015. Yeah, I think that's the end of this. Right, okay, thanks to all these guys. Nick Parsons, I've mentioned, energy surveys and retrofit installation. And he's based in Sheffield. So he's good for that sort of thing. The AECB, they're a great bunch of people. I can recommend them for any building work. I think, yeah, all these other guys are sort of, Tristan Lee, he's the guy I think I mentioned beforehand. He does heat pump monitoring. And so if you look for him, if you can't find him, get in touch with me. Same with Nick Parsons. Get in touch with me if you want to find them and you can't find them through a heat pump, through a Google search. I think that's it, folks. I think last slide coming up. And that's my house in 1977 when I first moved into it. It's a bit different now. So that's all from me, but I think Nicola's got...
well, there's loads of questions. Really good questions. One I think I'd like to ask, I can't remember who asked this one. What about hot water?
Ah, yes, I should have mentioned that. When I said keep things simple, I did think about a hot water system and I thought, oh no, this is going to make my heat pump less efficient. So what I have done is I've got PV panels in and I'm intending to put a system together where the hot water is heated by the PV panels. But at the moment, I just use direct electric for, well, I use direct electric for things like, you know, kettles and so on. And I have a wood burning stove with a back boiler in it, which gives me hot water during the winter.
You can, I mean, I know a lot of people do use the heat pumps to do the hot water, but I think the key thing is how hot does it need to be? Because most heat pumps, okay, it's not great, but you can get a tank up to 50 if you know, up to 50, even with a low temperature heat pump, it will do it. But you are told that you need to heat the whole tank to 60 degrees regularly because to stop Legionella bacteria growing and stuff. But I think it is fairly accepted now that you don't need to do that very often, like once a week would be good enough. So I think my favourite solution.
Yeah, once a month for Legionnaires.
So use an immersion heater to heat it up occasionally, but use the heat pump the rest of the time, but not too hot, because you don't need more than 50 degrees. You'll burn yourself in the shower with 50.
No, I mean, this is a good point. And some heat pumps, in fact, most heat pumps have a buffer tank. And if you're feeding from the buffer tank into your hot water system, well, then you've already got it up to 35 degrees. So, you know, you're not using your extra heating all that much. You can, yeah, I did think about it, you know, sort of putting in a circuit which diverted the heat pump so that, and it worked up to 50 degrees and whatever. But in the end, I just thought, okay, that's going to mean inefficiency that I don't have to have. And if I've got a highly efficient heat pump, well, then I've got extra electricity to play about with to heat the water. But it's a personal choice. I've done it my way, but I know a lot of people would prefer to get their hot water through the heat pump. And as I say, I've always got my wood stove, which incidentally is worked off wood that I've grown myself. So it's not one of these things where, the wood is imported or whatever.
Another really good question from Wookie. How small can you go? Because he reckons he only needs about 2 kilowatts.
Great, really good. My original one was 3 kilowatts. I'm a big fan of the 1 kilowatt heat pump because it ought to be really cheap. I mean, when you think about a fridge, that's a heat pump. It's just pumping the other way. And you can get a fridge for 200 quid. So you ought to be able to get a 1 kilowatt heat pump for 200 or 300 quid or whatever, and I think they're great systems. Like we know Tom's 3 kilowatt one was good. I mean, if you wanted to, you could have a 2 kilowatt one and, for an air to air, and that would be quite efficient as well. So, yeah, smaller the better.
And a question from Quentin. Quentin, do you want to ask this one about supplementary heating? Do you have a mic?
Yes, I do. Thanks, Andy. This has been very useful. Yeah, if you go for the small one and you occasionally need to boost it, you mentioned a couple of ways you could do that. I wondered whether you might do something boosting it with an electric immersion heater, or whether you could boost it with an air source pump like a fan blower air-to-air pump like Tom's, or whether you need to boost it in situations where the outside temperature is sufficiently cold that using a different sort of heat pump wouldn't be a good way to do it. And so I just wondered about, I do have a log burning stove, but it's not really in the center of the house. So
right. I do like the idea of having, you see, what I like about Tom's system is that at a later date, he could change his central heating and put in an air to water system. Okay. And when he did that, he'd only, try and find, say, a 3 kilowatt one or something, because he's already got 3 kilowatts from his air to air. So his new air to water one would work really efficiently because he's because only when it's very cold would he use both of them together.
Yeah. I think, and this is sort of related to what Andrew Urquhart's just does. So for me, one of the key things would be avoiding noise. I mean, I see the fan heater sort of effect is a very good one, but of course that's significant, probably, I'm guessing, significant background noise in the room that you're sitting in, which my radiators don't have.
Right.
But I'm also interested, and Andrew's asked about this, in this idea of a paired one. I mean, I think the quote we had for our house suggested 12 kilowatts. And I don't know, but I think those are units which have 2 fans in. I don't know whether that means they're actually 2 separate.
No, they don't work as separate. They have
Right.
two fans, but they don't work as a separate system.
No.
It's only that you have to specify to, a pair so that one half of it can be turned off.
Right.
And I know Mitsubishi do one with 2 5 kilowatts. I'm fairly sure other people do, but I don't know about them. But yeah, this is the problem. People will say, I mean, what size of house have you got?
Well, it's 4 or 5 bedrooms. It's actually pretty modern. I mean, they haven't done a survey yet. This was based on what they knew about the size of the house. It's reasonably modern, so fairly well insulated, but we are on the edge of a field and, strong winds blowing around us.
Yeah. that take into account that a lot of people, when they do these estimates, are wildly inaccurate. I think about 80% of heat pumps are oversized, probably more. You know, so
Yeah,
really is
probably
absurd.
they don't get fired for putting in one. They probably you get more complaints if it's not warm enough, don't they?
This is it. A lot of people just, installers, they're just thinking about comfort. So, they put in one that goes up to 50 degrees and then oversized and whatever, and so it is. That's why you've got this figure of 1.8 for the COP for the original thing from the Energy Saving Trust. It's an education system, but I do like the idea of these sort of hybrid systems, because then it's much more difficult to oversize them, if you've got 2 units that are doing something.
Yeah,
And
or the twin system.
Good.
I mean,
Yeah.
I think from what you've said, sorry, I'm taking far too much time here, so sorry. So do shut me up, Nicola. But I think the idea of actually 2 low power ones, obviously there's more hardware cost up front, but if you can get a matched pair like that, that sounds like a very good option.
Yeah, and it's not a huge. Well, I guess it's probably the difference between 2,500 and 5,000, for the basic unit. So it's not a vast amount of difference. And of course, I don't know what an 11 kilowatt one is. That might be 3,500, 4,000 anyway. So, the difference in price is not so much. Okay, yeah, thanks for that question.
Anyway, thank you very much. That's great. I'll let someone else get in there.
Okay, I'm not quite sure. I think I might have missed one, but there is one asking straightforwardly, I think, are ground source heat pumps more effective than air to air, having cost such a lot to install? Obviously, you said that there were potentially problems with the collector system, and I have heard that as well. But the trouble is that if you do have a problem with the collector system, it's underground, which makes it difficult to get at.
Yeah.
But theoretically, they ought to do a lot better because the ground doesn't get so cold, right?
That's right. In theory, they're better. You get a better RHI because they're meant to be more efficient. In practice, there are problems with them. And I do know somebody, a doctor who I knew, and he spent £20,000 on a ground source heat pump. And he was so annoyed with it that he couldn't get it working, and all these problems and people coming in after he'd spent all this money. As I say, there are more things to go wrong because they're not a factory unit. If they're right, and as I said, this company Rendesco that do these ground source heat pump installations. And when I was going to invest in them, I rang them up and, I thought, well, I'll speak to somebody. And the guy on the end of the phone was a German engineer. And Germans are much better on heat pumps than we are. And he'd been seconded to come over for 2 years to get Rendesco going. And he really knew his stuff. I learned quite a lot from him in the conversation about ground source heat pumps. So yeah, if you've got the right person, they can do it properly. But you get the wrong person, then it's an expensive mistake.
Yeah. Claire's asking about tank sizes, and is there a tank other than the hot water cylinder? I mean, I gathered that there is some water in the actual heat tank. In the heat pump, there must be something for a heat exchanger, but that's just air to water. I'm a bit hazy. Can you explain this bit, Andy?
Right, yeah, okay. A lot of, in fact, it's a sort of recommendation with air to water systems that you have a buffer tank, okay? Because that then means you haven't got sort of sudden shocks to the system. It starts up and there's water in the buffer tank and whatever. You don't actually need a buffer tank if you've got underfloor heating. My buffer, as it were, is several tons of concrete that that my underfloor heating pipes are embedded in. Yeah, if you do have a buffer tank, it doesn't have to be a big one. I'm trying
How
to think.
big is big?
150, 200 litres, something like that. Not big. you know.
Not small, but yeah.
Well, I mean, as I say, I'm because it was something I avoided. I thought, well, I've got underfloor heating. I have to say, you know, I know some people have told me about. It's not something I've investigated a lot because I thought, well, okay, you have to have it if you have it. One of the things I do think, though, if you put in a buffer tank, do have it to preheat your hot water. So have a coil in it, and when you've got your hot water, make sure it goes through the coil in the buffer tank, so it heats up to whatever the buffer tank is before it goes into the hot water cylinder. So when it enters the hot water cylinder, it's entering at, say, 35 degrees. So even if you heat it with an immersion heater, you're not going to use much electricity because you're just heating it from 35 to 50 or whatever.
So if I understand you correctly, I mean, the main thing about the buffer tank is that it helps to stop the cycling because it's a buffer.
Well, okay, it won't stop because the cycling's not so much to do with the buffer tank. It's to do the problem with the recycling is, particularly if you've got inefficient radiators and you're trying to put too much through the system, the heat pump will be doing its work and it can't do any more work because everything's heated up, so it'll switch off. And if it switches off every 10 minutes, like the example we saw, well then, yeah, you've got real problems. So lots of radiators working at a low temperature, but also matching it to the outflow of heat from your house is important.
Okay, Nicole, have I missed some important questions? Because it's almost time to wrap up anyway. Nicole?
Sorry, there was a more general question about whether they come in different colours and they can be sort of well hidden as part of your house design.
They aren't pretty on the outside.
Well, I guess they're not like Henry Ford, which any colour you like as long as it's black. But I think they're mostly beigey colour, so they sort of fit in with most things, you know.
And what about noise? So is it mostly on the outside part of the system, or a bit of both?
Well, this is
outside and inside.
Okay, an interesting issue because I find mine really quiet, and there is a lot to do with clever fan design. Now, if Tom's still here, I'd like to ask him how noisy his unit is in the room, because he's got this Hitachi system and it's blowing air into the room. Now, I suspect that it's fairly quiet because you can make fans that are very low noise if you use the right technology. But Tom would have to tell you for that.
That's right. So we're finding you can hear it if you listen, but normally we don't notice it.
Thanks, Tom. Yeah.
In terms of the rest of the noise, sorry, Andy, refrigerators make noises. This is a refrigerator.
Yeah.
So is the refrigerated noise that we hear the inside bit or the outside bit?
I think it's the compressor on the refrigerator.
So,
what you particularly hear with the refrigerators when the compressor's starting up and when it's stopping, they can be sort of noisy, but what happens in the heat pump unit is they sort of bury the compressor, so you don't hear much of the compressor noise at all. Or whether they have, I don't know actually about that, whether they have particularly quiet compressors, but I do know you can hear fridge compressors, but I can't recollect hearing a heat pump compressor.
And one more question, which is an important one from Tricia. How much disruption is there in having an air source heat pump fitted? Do all pipes have to be changed? What equipment needs to be located indoors?
Right. There is disruption. One of the you've got to have a sort of manifold for all the circuits to go together. One thing we haven't mentioned, which is important, is the more circuits you have in your system, the better. If you've just got one circuit where the temperature goes in at the water goes in at 35 degrees and it comes out at, say, 20 to 25 or whatever, that's not nearly as good as having 5 circuits. I think I've got 5 circuits, but 3 or 4 circuits is typical. That's quite an efficient system because you've got you haven't got a sort of sequence of radiators with the last radiator being at a much lower temperature.
Right.
So,
with a boiler system, you're coming in at sort of at 75 and it goes round all the way around the houses, all the radiators, and it comes back at what, 55, and that's fine. But if it's going out at 35 and coming back at 15, that's hopeless.
well,
So
this is
it
it.
has to come. That's why you need extra circuits.
You probably will. Yeah, I mean, the advantage is in having modifications there, you know. But those type of things, actually, you can put the installation in, and if it doesn't work, well, okay, it's a bit of an upheaval if you're replumbing it. It's probably just best to get the circuits right first time, but that it's not as drastic as having an oversized system.
Yeah. Okay. I think, I'm sorry there are more questions, but we need to wrap up. Is that okay?
Yeah, you wanted to say something because there's some more slides on here
Yes.
about. There you go. Yeah.
Yes.
Tom has got some stuff to say.
So I wanted to mention that Cambridge Carbon Footprint is offering thermal imaging training. And so it's a great way for finding out where your home is losing heat. And if you come to one of these training sessions to learn how to use a camera, how to interpret the images, then you'll be able to borrow a camera. But I'm afraid the booking system for these is not online yet, but it will be real soon. Just have a look on Cambridge Carbon Footprint in a bit. I hope that it'll be up by the end of the week. And anyway, I'd like to see you on those. Next, please, Nicola.
Oh, can I, sorry, we should point out that the training course is online. It's just the training course is going to be online this time, but
Yes, that's true.
you have to borrow the camera.
Yes, so we're doing training online now because of COVID.
Yeah.
We think we've devised a COVID-safe way of lending the cameras. So this isn't our scheme, but I'm just mentioning that there is this Cambridgeshire-wide scheme it's a group buying for solar electric PV panels with optional batteries. And I think it's a credible scheme. In fact, I've registered for, and the first round had an auction when 27,000 people had registered. And so they're now finding out which installer is going to bid for this potential.
Oh, Sarah Wilkinson, apparently, she says it's her scheme. She's the energy manager. So if
right.
got any questions,
okay, good.
We have an expert in the audience.
Okay, well, I'm just a punter with this, but anyway, before long we will get a quote for putting PV on our roof, which we can decide whether or not to go ahead with, and it should be installed by May at the latest. Okay, next slide, please. I think this is the last one coming up. And so there are still more tours. There are 4 more home tours in Open Eco Homes autumn season that you might be interested in. And so tomorrow there's a tour of a net zero carbon studio flat. There's going to be a tour of a 1930s home with a retrofit and extension. There's one of a Victorian home that now has 21st century insulation, a deep retrofit, and we're finishing on the 20th with a house that was built in 3 days. So at least it was erected in 3 days and made watertight from a German factory-built home. It's interesting. You could just click it again, Nicola. And so, can you write in feedback? Any other feedback you have? Write in chat what was good about this evening, and tell us if you've got suggestions for improvements or other things you'd like us to cover. And please, if you're able, donate something to Cambridge Carbon Footprint. We're relying on donations and grants to be able to keep this going and to provide more, but also to shelter that Andy mentioned at the beginning. I thought that was good to put that forward. So thank you, Andy in particular, but everyone who's participated. We're going to have a follow-up email, I hope tomorrow, where we'll link to a video of this session, and chat I will circulate again so you can catch all these links, and also a PDF of these slides which have some links in. So thanks very much. And
Right,
anything
thank
else?
you. Okay. Yeah, good to join you on this occasion.
Well, thanks very much for joining in. Anything else to add, Nicola, Nicole?
I think that's all, except for thank you ever so much to Andy, because it's been absolutely great. I was tearing my hair out trying to find a really good expert, and he's really stepped in and done the biz. We've really enjoyed it. Thank you, Andy.
Okay, thank you.
Yeah.
Okay.
Thanks very much.
All the best.
Bye. See you.
Thanks,
Bye,
thanks
folks.
for coming.